In this lesson of radical functions, we are going to be using our rational exponents and properties of exponents. So again, same review we've done for each of these lessons. Remember, the radical form, the fifth root of 7 squared, can be written in rational exponent form as 7 to the 2/5 power. So we're going to just quickly review rewriting an exponential rational exponent form or putting it back into radical form. So example 1, x to the 4/5 would be the fifth root of x to the 4th. Number 2, the square root of m cubed would be m to the 3/2. Remember, the square root doesn't have to show you that index, it's understood, but it would still be m to the 3/2. X to the 3/7 would be the seventh root of x cubed. The fourth root of p to the 5th would be p to the 5/4 power. X to the 1/10 power would be the 10th root of x. You can put the little baby one there if you want for that exponent. And our last example, the 10th root of r to the 11th would be r to the 11/10. Great job, good review. Okay, our next ones, we are going to be simplifying the radical or the rational expressions, kind of, again, reviewing things that we've done. So I want the square root of 4 and then raised to the 3rd power. The square root of 4 is 2, and 2 to the 3rd power would be 8. 2 times 2 times 2. Example 2, the fifth root of 32 raised to the 4th power. I'm going to take the fifth root of 32 because 2 to the 5th power would give me 2 if I take its fifth root. So that would return to be 2 to the 4th, and 2 to our 4th power would just be 16. Our third example, the cubed root of 27 squared. So that can be the cubed root of 27, which is 3, and 3 squared equals 9. And then our next one, explain, is the cubed root of 8 raised to the 2nd power the same as the cubed root of 8 squared? All right, so let's check. If we put it back into rational exponent form, the cubed root of 8 would be 2, and then I would square it, which would give me 4. And in the denominator, in the next way it's written, we have the cubed root of 8 squared, so I could rewrite that as the cubed root of 64, which is 8 squared. And 4 times 4 times 4 multiplied 3 times does give me 64, so the cubed root of 64 is also 4. So those two examples are exactly the same. Our next examples are in rational exponent form, and we can put them back into radical to help us simplify. So 81 to the 3/4 would be the fourth root of 81 and then cube it. The fourth root of 81 is 3, and 3 to the 3rd simplifies to give me 27. 64 to the 2/3 means the cubed root of 64 and then squared. The cubed root of 64 is 4, and 4 squared is 16. Next example, 36 to the 3/2 would be the square root of 36 cubed. So in this case, I might want to put that one in parentheses and raise it to the power on the outside, because the square root of 36 is 6, and then I can raise 6 to the 3rd power. And so that would be 6 times 6 is 36, times another one would give you 216. And we want to check, is 8 to the 2/3 equivalent to 8 to the 3/2? So our first one, 8 to the 2/3, means the cubed root of 8, and then I square it. The cubed root of 8 is 2, and 2 squared equals 4. In our next example, 8 to the 3/2 means the square root of 8, and then raise it to the 3rd power. The square root of 8 doesn't simplify perfectly. That would actually be 2 multiplied by the square root of 2, and then we would raise that to the 3rd power. And that is not going to simplify to give us 4. So no, those two are not the same. We would want to have the same root identical, or at least be multiples of one another in order for those to be true. So the product property for our exponents, if we have the same base being multiplied, then we are actually going to add the exponents. If we have the same base for a quotient property being divided, that's what a quotient means, then you are going to subtract your exponents. The power property means like x squared all to the third power. So I'm going to distribute or multiply the exponents. In our next one, the zero exponent property. So anything that you have raised to the power of 0 simplifies to be 1. If it's in parentheses, then everything raised, you would use your power property. So my example, 2x to the power of 0, that entire thing would still be 1. That'd be 2 to the 0 times x to the 0, and 1 times 1 equals 1. So if it's an individual term or if it's everything inside parentheses, then all of it simplifies. And negative exponents. Okay, so if it's negative in the numerator, you switch it to the denominator to become positive. And if your negative exponent is in the denominator, you do just the exact opposite. Switch it to the numerator so that your exponent will become positive. So if it's bad in the bottom, negative in the bottom, move it up top to be positive, and vice versa. If it's negative in the numerator, switch it down to the denominator and make it positive. Okay, so we have a few examples to go through. Leave our answers in radical form. Okay, so these are all in rational exponents, so we're going to simplify them and then rewrite them in radical form. So I have x to the 1/2 raised to the third power. That is a power to power. So 1/2 multiplied by 3 over 1 would give me x to the 3/2. And then to convert it into radical form, I need the second root or the square root of x cubed. Our next one, x to the 1/3 multiplied by x to the 4/3. This is the excuse me, this is the product property. So I will add the two exponents to give me x to the 5/3. Put it in radical form. That would be the cubed root of x to the 5th. And our next example, x to the 3/4 divided by x to the 1/4. That is the quotient property, so we are going to subtract the exponents. So 3/4 minus 1/4 would give me x to the 2/4. That does reduce, so go ahead and reduce it to be x to the 1/2 power, which in radical form just means the square root of x. Or you could write it x to the 1st if you want to see that power underneath your radical symbol. We have another simplifying problem with the quotient property, x to the 1/3 divided by x to the 2/3. So I'm going to take the 1/3 and subtract the 2/3, which would give me a negative 1/3. So x to the 1/3 divided by x to the 2/3 simplifies to be x to the negative 1/3. And remember, we don't want a negative exponent in the numerator. So I'm going to take this entire term and flip it to the denominator. So this will turn into 1 over x to the 1/3 power. Now it's positive, the exponent. So I'm going to rewrite it again back in radical form. X to the 1/3 means the cubed root of x, and that's all in the denominator with a 1 in the numerator. All done. Great job, guys. In this next example, you'll notice that not every single term has the exact same denominator for the rational exponents. I have x to the 1/4, y to the 1/2, and z to the 3/4. So in this case, I can't do anything with any of the terms because they all have a different base, but I can change that middle term, y to the 1/2 to be y to the 2/4. So it's x to the 1/4, y to the 2/4 power, and z to the 3/4 power. And then in that case, I can rewrite it in radical form with the fourth root of x to the 1st, y squared, and z cubed, or z to the 3rd power. There you go. And last two examples, then we'll be done with these. These two, I want you to leave everything in radical form. So we're going to use our properties of exponents do what we got to do, and then put it into radical form. So I have x to the negative fourth y squared z squared, all raised to the power of 1/3. So this is the power to power property. I'm going to multiply 1/3 to each of those exponents. That will leave me with x to the negative 4/3, y to the 2/3, and z to the 1/3. I do have a negative exponent. Right now, everything is over 1, but I need to take this term with the negative exponent and put it in the denominator to make it a positive. So we will have y to the 2/3, z to the 1/3 in the numerator, and x to the positive 4/3 in the denominator. Now in radical form, all of the roots have to be the same. That tells me the index, or the little number outside of our house, and they are all over 3. So I'm going to take the cubed root, and then I'm just going to rewrite that fraction as it is, but I'm going to change them to be y squared multiplied by z all over x to the 4th. And you could simplify x to the 4th, the cubed root of that. It actually could be simplified, but I'm going to leave this example just as it is for right now so that we don't cause any confusion. Okay, our last example, 8x to the 9th, y to the negative third power, all raised to the 1/3. So I'm going to take every single term, again, that power property, multiply through to each power. That's 8 to the 1st. So 1 times 1/3 would be 8 to the 1/3. X to the 9th, that would be x to the 9/3. And y to the negative third would be y to the negative 3/3. Remember, if you need to see what x to the 1/3 is as a radical instead, then you don't have to simplify it just yet. It will equal 2, but I'll show you in just a moment to prove it to you. X to the 9/3 would simplify to be x cubed, and y to the negative 3/3 would be y to the negative 1. And then the only thing I would have to do is the term that has the negative exponent needs to change into a different position. It needs to go from the numerator to the denominator. So this would simplify to be 2x cubed all over y. That answer is absolutely perfect. Again, if you wanted to take a step and show the cubed root of 8 and then x to the 3rd, y to the negative 1, you could do that if that helps you remember that the cubed root of 8 means 2 times 2 times 2. So that would be 2x cubed y to the negative 1, and then again take care of that negative exponent term to give us 2x cubed all over y. There you go. That's it for this particular set of examples. You guys should be working some on your own on worksheet C to practice so that you are ready with any questions that you have.